Okay. All right, so we couldn't do that, but this works. All right. Hello, chat. Let's close this. Hello, hello, hello. I am back, and today we're gonna continue working on our library. I feel like we're pretty close to a good milestone. So yeah, I'm excited. So let's take a look at our progress, shall we? Let's begin by going to GitHub, the repository here. We have 300 commits in the main/master branch, and 390 over here. Okay, so what happened here? Let's see. There's some test failures apparently. Okay, we need to update. All right, let's do this first. Let's fix our branch. So I need to run make code gen. Let's bring up the font size for the stream. Hopefully that's better. Hope you're having a good day. There we go. Update test manifest. Okay. All right. Let's take some notes. Yeah, I've been thinking of a few AMP ideas. So I think after we achieve some milestones on this library, we'll build a few Mac apps or even iOS apps in Swift UI. So I have a couple of app ideas that I actually really need those apps to exist. So yeah, that'd be great. So here's our like a Kanban board kind of thing. We've got 12 to-dos. So let's start on the top. I think this one is fairly easy. Oh, let me show you I guess let's begin by showing you the progress. Yeah. So I made some progresses while not streaming. First one is, I really like this one, is make the binary string go faster. So I guess let's go to a pull request and look. Make binary string. So as you may know, I store the path, the content of a path, not the file it points to, but just the path. It's the text of the path. It's stored internally in their binary format as provided by the OS. And before I was using a contiguous array. Now I've introduced this new type. Actually, this is not necessarily better, is it? Let's go here. Binary string. Okay, so I've introduced this new type called a C string, and it still uses the contiguous array, and it takes a generic parameter, which is a binary integer. So this contiguous array of integers is the raw storage, except when I actually, let's make this private, by the way. When I actually want to use the content of the string, I use this content variable, which is a subsequence to a contiguous array that just drops the last element in the list, right? So why is that? The reason, well, I actually wrote a whole blog post about this, which is pretty interesting. And the blog post is titled "Faster C String in Swift," right? So the reason for this is the reason for this is we want to. Okay, sorry, one second. I wonder, so the streaming platform is telling me to check my settings. Maybe something like this. Okay. Anyways. Sorry about that. So the reason I needed the binary content for the path representation is that I want to be efficient in the case where we just get some path from C API and then pass it back to some C API. The deal with C API is that they take so-called C strings, right? So, for example, in this Windows API, it takes this LPT_str type, which is really just a wchar wide character array, and they don't take the length, and they infer the end of the array by reading it from the beginning until it reach a null character or a 0 in value, right? So it's very important that when you give a C API a piece of memory, the 0 appears at the right location. 0 must appear where your content ends, right after. Otherwise, the C function C API will just happily keep reading until it encounters a random 0 in the memory, following the start of your pointer. So so that's number one. And number two is, before I was not storing this extra bit. First of all, this is the reason we need to chop off the extra bit. That extra bit is the 0, right? So let's take an example here. This is when I take a C pointer. The first thing we do is, I guess, iterating over the content until it's 0. We're just simulating what a C API would do, right? So we're given a pointer, and then we're going from the beginning of the pointer, right, 0, advanced by 0, until we see the pointee is 0, right? So this is what exactly the C function does. And through this little exercise, we'll get the length of the actual content in this string, quote unquote string, right? It's just really just an array. And then we will allocate that length plus 1. And then we iterate over the original array, copy the content, and then we take the last content element and set that value to 0. So the reason, so this way, when we essentially copy a C string, we attach that sentinel value at the end. So this is always going to be in the storage. And when we need to interact with the C API again, giving back this piece of memory, I believe it's defined somewhere here as well. Yeah. So we just literally just say, hey, go ahead. Here's the pointer at the beginning of the memory, the contiguous array, and the C API will, find the content and then find the end by the extra bit, extra 0 we're throwing there. So it's free. It doesn't cost anything. Whereas before, without this extra bit, we have to, because we still want correctness, right? So we ended up having to, every time we interact with the C API, we have to reconstruct the entire memory. So adding a 0 at the end. So the code before was like, maybe I can show you here from the pull request. I just search for the thing. I talked about this on the stream before. So this is how I used to pass the memory back to C API. So I have self. Self in this case is a contiguous array. But because we need to let the C API know where to stop reading, we ended up having to add a 0 at the end. And the cost of this is like we thrown out the benefit of storing the binary string directly, because each time we pass back to the C API, we have to allocate a new piece of memory and then put this, like the addition result, which is a new array with an extra element, into that piece of memory. And then we take the pointer from there. So it's very slow. And whereas now, this is free. There's no new allocation, there's no copying, and we get all the benefits. And then we also have the content here to ensure that when we are care about the content, we actually look at it. We get the right amount of, we get the content, the right amount, with the right length, and every element, but without the extra bit, extra zero at the end. So when we care about the content, we get the right content. When we care about the C efficiency, we get the efficiency. So that's the thing about the C string. So I'm very proud of this change. Okay, next, what I did offline. Well, yeah. Let me just C string explain. It's fine. And then, so what next thing I made offline is, okay, temporary directories, right? So this is actually very significant development. So I'm just going to open up, I guess, the source file here. So temporary directory, as a file system library, it's very common that a user wants to create a temporary directory, do a bunch of stuff in there, and either copy out the result of the work they did there, or just destroy it after, because it doesn't matter, right? So this is what this piece of functionality does, and it's actually more complex than you think. You'd think the process goes, okay, the system usually have a temp directory, right? So you think like you just create a random name in there, make a directory in there, and then give it to the user, and then the user do some stuff, right? Simple. But I ended up having to create 1, 2, 3, 4 separate pieces of interface to get this correct, across different platforms, and just in general usable. So let's walk over all of these, right? So I guess the first one, let's start from here. So this is a static variable called default temporary directory. And if we just read over this, it's not necessary, but just know that it's one of the paths, the primary path type, right? So, okay, that kind of makes sense. And, every system has a default temporary directory. On Unix, this is not just /temp. We'll talk about that later. So let's move on. So then we can see that its value is calculated by search for default temporary directory. And this is also public. I guess let's walk over what this does, and then I'll explain why this is needed. Anyways, we'll go back to default temporary directory then. So this function, it walks over a list of candidates to determine what is the proper default temporary directory for the entire library to use. Okay, because it's a static variable, so this calculation is actually 1, lazy, and 2 is cached, right? Once you access it, this function gets called. It performs a bunch of tasks. They're potentially expensive tasks, okay? And then the result is cached. So next time you use this, this function won't execute until something else happens. I will talk about that. But this function, it first searches through 3 environment variables. And then if any of these is defined, then it will construct a path based on their value, right? And then return it. So that's a path, number 1. If none of this exists, then we search through 3 locations, temp, var temp, user temp, right? If any of these exist, then we will return. And then we'll go, if usually at this point you would have found something, but if that's not the case, we can move on to here. And in the home environment variable and user profile, which is equivalent to home on Windows. Anyways, so we search through, and then eventually we fall back to the current working directory. We search through all these candidates, and the first one that has write access gets picked. Okay, so that's how we select the default temporary directory for, and then we assign that value to the default temporary directory. So one, user can read this value themselves if it's needed. But number 2 is user can choose to override this value, right? So if you wanted to perform some work with the temporary directory thing, but also you want to, for some reason, keep those work around, just in case, right? You can just set this to any library. And then when we construct a temporary path, this is private, by the way, we will use the default temporary directory as the parent directory for everything. Okay. And then this is why we make this search for default temporary directory a public interface, just in case you want to set the library back to the original value, right? And also, if for some reason you know that the default temporary directory changed in your system, for example, you defined one of these environment variables and then you undefined it, something like that. Then you can use this function to calculate the new candidate for all the parent default directories. Anyways, so the rest is actually simpler, right? This is, we're getting closer to the simplified version we started with, which is like you can construct a path with random naming here. So this is not super interesting, but we know that the parent is guaranteed to be writable. And then we can make the temporary directory, and that this is simply exactly that. You make the path, and then you make the directory, and then you return it. Otherwise, this is the actually super important one, which is with temporary directory, it's static method. So all it does is make the temporary directory, set it as the current working directory, call a closure in this context, in this environment we set up, and then we will reset the current working directory to whatever it was before. So this is what, when this goes out of scope, that will happen, and then we'll delete the temporary directory, okay? So I said this is very important because guess what? If you really want to write unit tests, almost every single test needs to call this, right? Because think about it. The only other you can ship with so-called whatchamacallit. Anyways, you can ship with like predefined file structures, sure, but for things like creating a directory and deleting them and all the copying them and changing the signature and things in that nature, it's really difficult to have a static set of files to satisfy all you need. And the really, I think, in my opinion, reliable way, semi-reliable way is make this super solid and then just like set up your test in a temporary directory, do whatever manipulation you need to do to the temporary directory, and then check the result, and then rinse and repeat, right? And then because how this is set up, the test will get cleaned up automatically because of this. Yeah, so that's the reason this function is super important. It is so that we can actually write a lot of tests based on this. Anyways, yeah, so sorry, I normally don't do this much explanation, but I think this is very interesting and I'm very happy with this outcome. But I guess let's do some work next, okay? Let me see. Make binary string storage private. Okay. Explain temporary. Okay. Okay, let's get back to our task. So I want to work on this. Let's just go to the issue. The issue says when you delete a directory, we first move its content to a temporary place and delete them there, and then delete the folder. Problem is that when we currently use the get temp directory from Windows, notice this is actually overlapping with what we just talked about. This API doesn't guarantee the right access. Okay, so as I just showed you, every time we search for a default temporary directory in those lists, we check whether it's read-only. If it's false, meaning it is not read-only, it's writable, then we will return it. Otherwise, we'll keep searching. Okay, so this is certainly the better version. The default temporary directory is the better version of this. And it's very important because all the reason we need a temporary directory is so that we can move file into it, then mark them as deletion, right? So we essentially need to update the implementation for delete, okay, to use our own built-in temporary directory function. So let's do that. Func delete. Okay, so there are two separate implementations, no problem. The first one, oh, we don't need to care about this because this is the POSIX version and it doesn't have that quirky move before delete behavior. All right, so it's this one, get temp. Okay. So as you can see, we're doing a lot of work here just to get the temporary directory here. We can delete this, right? Because this whole thing just gives us the default temp directory. And this is a temp path. Temp path. Did I really actually use the temp path? Okay. Oh, use it in a couple places. Okay, so we can delete this as well. So this is great. Tab pass C string. Great. So what we need to do is call make temporary directory, really. Don't care about the prefix and postfix, really. In fact, why don't we just use with temporary directory? See, it's so useful. This thing is almost always the better version of the other one. So when we call this, we have a temporary directory. No, actually, I don't want to use this. I changed my mind. Okay, let's do this. Path, temporary directory, make temporary directory. Okay, let's throw a try at the end. Throw a try. Put a try at the beginning. Then so we need to get a C string from there. So, but I can get rid of this block because we did that elsewhere. We take this past C string because we're moving it there, and then that's the from C string, and then this is the temporary.c. binary.c. Oh, wait. Yeah, we still need the block. Okay. Okay. So I guess we can do this point free style. All right, so we literally just replace that call, this local function with this call, and we should be good. Okay. Temp. I think this will fix our problem, but the problem was not. It's kind of theoretical. It's like, if Windows, when it gives you the temporary directory, it just checks like a list of environment variables and give you the first one. It doesn't really check whether it's writable for you, but maybe most of the time it is. But so like, there are scenarios maybe that are not writable, but it may take some effort to actually construct it. But I'm gonna assume this works, and let's make a branch for 212 and put up the pull request. Look at that, code deletions. Guarantee writable temp directory for Windows path dot delete. Okay. Yeah, I pushed up the branch, and then I will log into our Windows machine. Set up the shell environment. I think this is the only test we need to perform, so let's do that. Let's go to PowerShell, build. This problem again. User dan app data local temp org. I overtyped. Okay. Let's do build. Actually, we can just straight up go to test, because test builds first and then test. So if things build, I expect the test will pass, because we don't really have very, very serious unit tests for deletion, but we can now, like I mentioned. Well, there are still a couple of things like making a file, which is essentially writing an empty file or something. It's those things are good to have, because then you can say, okay, write a file, make sure it exists, and then you call delete and make sure now it doesn't exist, right? And that verifies that the delete works. And this compilation is not making progress, which is concerning. Concerning. What happened here? Well, let's also, I forgot to check out the actual branch we need to test, so maybe that'll help us. Something changed here. I was writing some tests. Actually, I would like to keep those around, because this code we may directly use in today's development. So, I'm concerned. Okay. Actually, let's recite something. Delete the build directory. Run the make. So set up the CMake. Okay, and then we run test. Is it going to do anything? Is it not happy today? Uh-oh. Okay, what about CI, huh? Let's make a pull request here as well. Maybe we'll just use CI for this issue, because I don't really want to dwell too much on it, too long on it. Wait. There are 2 commits? Okay. That's not good. Let's fix that. So that's the hash. Check out next. Set hard to this. We'll just push this up. Now, if I make this pull request, should be just 1 commit. Nice. Close. 212. Link issue. Okay, so we'll just let the CI run. How about that? Because for some reason, could not build C module Win SDK. That's a new one. I wonder if it has anything to do with my local changes. So let me delete this graphics thing because that's just an imposter. Everything else I'd like to keep. Status. Okay. So examples. Stash. How about that? Okay. What if I build again with these changes? Because for some reason it's building Win SDK before. Yeah, okay. Now things are running. Okay, one failure. That's not great. Ha 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 ha. Where's the failure? Test with temporary directory failed. Temporary test with temporary directory. Uh-oh. Okay. Let's run it again. Build Windows bin Windows main. Pass those tests. Temporary tests. Yep, that one failed. File exists. Looks familiar. Test with temporary directory. File exists. I like this error message. It's in the right tense, English tense. Okay, let's take a look at that. Oh, this is rough. I forgot how rough this is. Okay. What is it called? Temporary tests. This is like a test with temporary directory. So this is the test. Can I redraw everything? Okay, redraw made it worse. Okay, let's switch computers. Boop, boop, boop. All right. Okay. Can you guys see this? Nice. All right. Where were we? Temporary tests, right? This guy. Hello? Whoa. Who changed my keyboard layout? Okay. With temporary directory failed. Okay, let's open this guy up. I keep forgetting this is not Unix. Oh my god, so painful. I was using the tmux shortcut trying to open that, paste that file there. That's why you saw that little Y with temporary directory. Okay, so let's just try to eyeball this, right? We make a temporary directory. we set it as, okay, this is the same implementation. So really we need to look at how we're making the temporary directory. So when we make the temporary directory, we construct a path and then we call make directory, right? So really things could go wrong in make directory. Func make directory, hello, make directory in Windows, right? So that'll be in this file. Sources, pathos, Windows, path plus Windows. Okay. So make directory. Let's read this. Actually, I don't want to read this. I just want to debug this. So how about we do this? We put in function here, and then we just print out self. Right? Every time we actually attempt to make a directory, we will do that. Make directory with parents, and there's some segments left. Wait. So we threw the error saying file exists, right? Anyways, let's see first of all if we are trying to create the same function twice. Sorry, create the same directory twice. So to do this again, and then we can do this. Oh, not really. I don't need to do anything because I already built the thing. Oh, I need to rebuild it, I guess. Okay, script build. I should just remember to not use the SSH. Every time we end up here anyways. Okay, delete this guy, yes. And then we build. We're making progress, there's some warnings, blah, 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 but we built it. And then we can do this. We got our failure, but now we have some cases to look at. So we make this, and then we make this. Things look okay here, right? We're not making the same directory twice. So that's the good news. Path plus Windows. Okay. But we threw an error regardless. And we're trying to create two temporary directories, this one and this one, in that one test, right? Let's make it more specific. The test name is test with temporary directory, so we'll do it exactly like that. Wait. Temporary tests. Test with temporary directory. This doesn't work for some reason. Okay, we'll just run it like this then. We have two failures. Temporary tests. Why would there be two failures? That's my first question, right? With temporary directory, so I guess we can go there, temporary, with temp, okay. Hello? All right. Make temporary directory as working directory, okay? So just for the debugging, wait, what happened there? Why did it insert all this white space? Okay. Just for funsies, let's put on some traces for this call. I just want to make sure it's not called twice. Build, sorry, scripts, build. Okay, so it is called once. All right, that means when we create the directory with the recursive being true, for some reason, we're creating two separate directories. Path plus, oops, Windows, make directory. This gets called twice. So once here and once here for some reason. Wait, the real issue is the parent exists through an error. Okay, so we got an error here somewhere, but the error is not parent file exists. That's the real problem here. Okay, let's run this and see what this error is. Wait, did it build? Print error. Okay, it did build. Then we run the test. It printed a bunch of stuff and it didn't see an error? No way. So it didn't throw an error. Does so? What I'm thinking is, we're checking whether this is false. So that means when it's false, we look for errors, right? But that's fine, because like we're getting an error thrown, and if it's thrown, that means we threw it. Oh, by the way, CI failed as well. Interestingly, I'm guessing it would be the same error. Yeah, one failure. If I search for fail, okay. Please don't hijack my keyboard search. All right, it did something. Okay. Failure. This one. Yeah, it's the same. Same failure. Okay. Cool. I guess we're fixing this test failure then. Okay, let's check while we're here. Let's check the documentation. Okay. I'm gonna blow this up for you. Actually, there's a window here perfectly ready to be searched. Create file. Wait, what am I searching for? Create directory W. Create directory W right here. All right, so its return value, if it succeeds, is non-zero. So if it fails, is zero, means false. So when that happens, we throw an error. Okay, so the error, let's switch back to the code. The error here is not thrown by this line 127. So what could it be? Sorry, I just realized that I use this like app, which is just wrapper for web view for chat, but it's very buggy, not surprisingly. So if anyone said anything before I didn't see, I apologize, and but I can see it now. So thanks for being in the chat. Okay. So the error is not thrown over there from there, I think. Just to make sure, let's do this. You guys can see this, right? Okay, just to make sure, I'm gonna just catch the error. What the? Okay, I'm just gonna catch the error here. Do catch throw error. And then print something if error happens. Just make it super sure is not being thrown from here, right? Let's build, and then let's run the test. Yeah, I'm not seeing that. Okay. So the error is not thrown from here, which is super interesting. Then let's look at temporary again. It's gonna be from here then. Wait, what are all those changes? This looks funny. What? How about Oh, some indentation, right? Okay, I don't care about that. All right, so the error must be thrown here. Make temporary directory. I'm gonna assume this is not throwing the error. Do catch throw error print function through. Okay, I'm gonna assume that's not the thrower, our mystery thrower. Who threw? Who threw the game? Whoops. So that guy didn't throw. Because all it does is to call the make directory, right? Okay, so it's delete, right? It has to be delete. Delete is throwing. Wait, the error is file exists. All right, let's just do this a bunch of times, okay? This is Pepega debugging, but I think at this point, because on Windows, I don't have enough working tools, so I'm just gonna do this for now. Throw error, print this guy. Let's just sprinkle this all over the place until we succeed. Okay. So this guy could throw. This guy could throw. So let's do this as well. Throw error. Print. What is this? This is as working directory. Why would this error out? Okay. Build test. Oh, I got something. What's this? Hello? It says function. Function. What the heck happened here? Oh, it's this guy. For some reason, I put it in interpolation, but actually, so it ended up printing. Oh, yeah. Okay, so delete is doing something weird. File exists. Okay, so I think we've narrowed it down a bit, right? Just to make sure, let's just do, I don't know, hoggers. poggers. All right. So delete is failing. Func delete. Isn't delete something we just worked on just now? Path plus Windows. It's in the same file, isn't it? Okay, delete. All right, so this is failing. So what could throw an error that says file exists? Okay, let's just first say deleting self, right? Let's just print out what we're trying to delete here. Okay, so we made this directory something 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 for 0, and we're trying to delete it later. That one worked. Wait, what's printing success again? It's in temporary, right? Temporary. $130. Aha, it's this guy. So success means making directory succeeded. Okay. I'm gonna keep this around so that we can match them with the deletion message. Okay. So this is the last test where it says poggers. We make this directory, right? Blah, 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 582, and then we delete it. So that one didn't throw an error. And then we made another directory, blah, 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 and we failed. Okay. And the interesting thing is, we didn't see a message saying delete here. I wonder what that is about. But I guess the first thing I'll do is put everything here into a big do statement. Throw error, print, deletion failure, error, and then literally everything here goes in. Everything here goes in, and then we can build. So, just give me a window looking at deletion failure file exists. Okay. All right, so we can now gradually move things out until we narrow down which line is problematic. I don't think that part I just moved out could cause the problem. Okay, so then what? If the file type is directory else, I guess we can wrap the if branch first. It is in the if branch. Okay. Let's keep going. So if branch has an if recursive. I believe we're dealing with recursive. So let's put it in here then. If recursive. This is like a scope that you're like moving around the code base until you see the thing. Deletion failure file exists. Okay, it is in here. So this code actually makes another temporary directory. So it's like to delete a temporary directory, you need to make another temporary directory. That's pretty funny. And what do you know? Of course, this directory is problematic for some reason. Let's make this a separate statement. The tempter, okay, print temp. Well, I assume this line is the problematic one. Made. Wait, it is not the problematic one. We saw this line. That means this executed successfully. Okay. So it's really in here. Okay, we're getting close. Well, what if so here we take the temporary directory string, take the binary string. So what if I print out tempter and self, because we're moving to this from this. Oh, move file W. Is this what's being thrown here? Moving failed. Yeah. Okay. That's interesting. Move file W. Okay. So the problem is that we're trying to move one temporary folder into another temporary folder, but what we end up doing is moving a temporary folder as another temporary folder, and then we encounter an error. Move file function will rename either a file directory. Yeah, if it's renaming, then it's obvious that if you're trying to rename it into a different thing, then yeah, including children, either in the same directory or across directories. The one case is a move file function will fail on directory moves when the destination is a different volume. If the file is across volumes, move file on the corresponding operation. Okay. So I want to take a look at whether there's some special things done in the current iteration here. Manipulate. Okay. Hey, Mark Sands. Yeah, actually, what you said is actually correct. I mean, the file exists literally means the target directory already exists. The problem is like we're expecting the first temporary directory to be moved into the second directory, but actually, what API does is it's trying to move the first directory as the second directory. Think of it more like a renaming. So that's why it failed, because obviously you can't rename to something that already exists. So this is the current. Okay, let's read what POSIX does. Man to rename. Calls the link to first removed. New must be the same. File system. In the middle. It doesn't say much about overriding. Moving or renaming file into a directory with inheritable that does not result in use this. Okay. Okay. So maybe we need to do some manipulation. Oh. Well, thanks for writing that. Yeah, and also I apologize for not reading your comment earlier. Yeah, I was too focused on the debugging. It is an interesting problem, but I think there's an obvious solution, which is like we just take the name of the destination of the source, and then join that. Yeah, well, let's just do that. You know, life is short, right? So I'm gonna. What did we do here? Did we actually do anything other than debugging? I feel like I didn't write any code, right? So I can just throughout all of this. Yeah, when I write on this machine, on this Windows machine, I tend to read chat slower because I'm looking at a full screen window. Okay, so I basically threw out the changes, local changes, so we can start over. Here, what we're doing is we make a temporary directory, and then we have the current directory. We want to move the current directory into the temporary directory, right? So we need to do it in 2 steps. Right. So let's make the temporary directory first. Let temp equals this. Easy. And then we need to make the let target be self.name. Well, what if we don't have a name? I guess if a file doesn't have a name, then we don't do anything about it, right? Because name is optional. Okay, so I guess we do this first. We guard let name target guard let name. Otherwise, we just return. That's good. Okay. So now we have a target name, and then we just do temp, I guess, joined with target name. So that's our temp string. Yeah. Okay, so this should fix that. This should fix it. And this is duplicate logic here, so let's just duplicate the code as well. I don't want to overthink this too much. Although duplicating code is just always a little icky. Just a little icky. Okay. Whoops. What happened there? Okay, so now let's do the good old build and test. Build, test. And we have 0 failures. All right. Interesting. Okay. But why didn't this problem exist before? It must be something we did today, but I'm gonna checking this change first. Fixed deletion, I guess. Windows. What branch am I on? Is it unique to this branch? Oh, sorry. I just switched computer in real life. Okay, so let's review the code a little bit. Because this branch did start off deleting all of this, right? So I assume when we were doing all of this, things were working okay. But how? Oh. 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 So when we did this before, we search for the parent directory, and then we just create a temporary path without doing anything with it. Whereas here, we did create a temporary path. Before we were using this as the target. So we'll create a temporary path. We just move something to that path and mark it as deletion. Interesting. Interesting. So that's why it did work. See, this thing doesn't exist. It's just a string at this point in memory. And then we move the whatever this file is to have that name. And then we mark it as deleted. Huh. Whereas now we make a temporary directory. You know what? I actually like this less, right? It's more complex and it does the same thing and makes an extra directory, right? It's slower a little bit. And we have to do this join. Yeah, I actually like this less. Huh. Okay. Reset head. Let me think about this a little bit. Okay. So discard the change we just made. Maybe what I need here is something like path default temporary directory joined. Well, it's a little verbose here. What if I make something like func temporary name, path, and it's the default temporary path joined with a random string, which is I guess let's just do the basic random ing 0 dot max, right? So we just take a temporary name every time and use it like that. Temporary name. Okay. How about that? Script build. Path has no default temporary. It's not temporary path. It's gonna be temporary directory because that name makes more sense. It's a physical directory that we verified it both exist and that we have write access. Okay. Nice. And assume the test now will pass, right? Because we understand what happened. Yep. There's no reason to think otherwise. Okay. I guess this is just the same part of the patch. Fix up. Part of the same patch. Origin. Okay. Wow, that took surprisingly longer than I anticipated. Okay. I thought this is a warm-up. There are two commits. One fix up the other. Okay. All right, I'm gonna, I guess, let that run because we know it will pass, right? So let's move on to the next thing. Fix issue 212. Okay. So let's pick a next thing. I as I mentioned, I stashed something here. Sorry, what have you been looking at? You've been looking at my Windows machine. Good. Because I forgot to actually set it. I'm sorry. Set hard origin next. Pop. Samples. Okay, so here's my, I guess, admission of guilt. I actually worked on this little experiment where I tested out get final path name by handle. And I think, well, the reason I tested out is because I need to use it for reading symlink. Okay. So let's implement that. Yeah, because I know that how to do it on Windows now. I'm gonna do it for POSIX first though, because that's our home and we like to fix up that first. Read symlink. Okay, let's go. Everything up to date. Okay. Read symlink. Okay. So read symlink obviously will have two separate implementations. So let's go to path plus POSIX and just add the thing on the end. Public func read symlink. Is that good enough? Probably. Throws. And then it returns a path. Okay, because symlink points to something. I think. Wait, do I need to implement read string first? Read bytes first? Read write. Or is it on symlink? Read symlink. Read symbolic link. Read symlink. Oh, good. We have read link. Perfect. Something weird is happening here, but let's just read the POSIX manual for that. Read link. Okay. Read link. Returns error code with buff size. Okay, so we need to supply the maximum buffer size. Does not append a null character to buff. Okay, cool. And we don't get to cheat here. Okay, fine. I'm curious about this. Let's search for. Let's see what past Daniel did in terms of length. Path max. Path max. Path max is tricky Path max is 496 bytes. Is this a thing here? I guess Mac OS path max. Yeah, I don't know. What am I to do here? Okay, I guess I'll do. Oops, shouldn't show that. Sorry. Let's define those, okay? Because I have a namespace for constants, right? Constants, Windows constants. Yep, Windows constants. Let's just define path max because I know that, for example, var max path length is integer of max path. I think it's like one of them is path max, the other one is max path max. And okay, so this shouldn't be here because this guy is all right, how about we just define it in this type alias thingy, or just say extension constants let path max path length. Yeah, I got by so far without doing this, having to do this. It's gonna be an integer, and then we can do like a if I guess max path. This will be an int to max path. Else if path max, it'll be path max. I think on Windows, one of these is guaranteed to exist. Windows path max Windows. I think this story on Windows is kind of max path is on Windows. Max path. Okay, so this is for Windows. And this is path max. It's a bit problematic. Not to be defined a constant. Have to be returned using yeah, I'm not defining it as a constant, am I? Okay. And then also there's also this. I guess I can, let's look it up. This is an interesting title for an issue. So it's 4K. Each path is 4K. Which is pretty interesting. Yeah, but like you have to balance, I guess, between file name max. Oh, it's defined for Microsoft as well. I guess because they're trying to implement the POSIX APIs. Okay, file name max. All right. Fine. Else, let's use a constant. And if. Okay. This hurts. This, I'm not gonna lie, it's pretty big. Oh, right, I can't store these constants here because they needs to be static, right? That one is fine. Okay, 4K per path, dude. What if I make these public? Public. And then we'll see what value we get in a sample app. I keep pressing the wrong key. Okay. Let's run ls, right? ls. Before it does anything, we'll just take the constants. Pathos.constants dot what path max path length. That sounds more grammatical. Max path length. Okay. Then Swift run ls. Oh. 136 pass plus POSIX. Oh, this guy. Let's comment it out. Yeah, it's 4096. So wasteful. Okay, constants. So the next thing is like which one of these is actually the value, right? Let me just change this into some arbitrary number. Make sure that one is not the case. Not the. Oh, that is the. We're using a fallback value here. So none of those were actually defined. I'm really curious as to what is the value. What if I make a C API? Hello.c. Oh, sorry. Hello.c. Let's include standard IO. Main. And then all I want to do here is printf. Then I don't know what it is. Let's try just a number. And then return 0. And then let's put, what is it? File name max. See, it is in the autocomplete. So let's see what this value is. Clan. Hello. Okay. It's 1024. So let's go with 1024. Yeah, I like that. Constants. 1024 is very large. It's 1 kilobyte. Okay, now I'm curious as like what is the actual value on Linux. So I'm gonna hide the video for a bit. I'm gonna keep talking. So I'm trying to log on to one of my DigitalOcean machines. If I can, please. Uh-oh, it's not looking good. I'm signing in to DigitalOcean to check the IP. Okay, that's the IP. Oh, thank God, okay, sorry about that. I just want to write the same little program and kind of see what happens there, right? So hello.c include standard IO int main, and then all we want to do here is printf command D file name max. Isn't that interesting? It got highlighted as finished typing. Do I have clan here? No, but I have GCC, right? Okay. Doesn't matter to me. It is for 1496 here on Windows. Also, I realized this constant was not imported because I probably didn't import the correct headers. So yeah. If OS is Windows, import WinSDK, else, and if can import Darwin, import Darwin, else, well, else import glibc, and if this one is for this, and then this one is for that. Okay. So now we should get some more constants. I'm going to change this to the weird number again. 777, I don't know, any number. Please, just let me edit. Okay. And then did I do Swift wrong? Yeah, okay. So it's still that number, but now I can check file name max again. See if that works. No, it still doesn't exist, huh? Wait, no way. This seems to exist in a lot of places. I'm just going to comment everything out because these are just confusing me. Yeah, it does exist here. It does exist here because we have the standard C headers. That makes me wonder if path max exists. Oh, it exists too. Nice. So maybe this should be like this, right? We just define them separately. This Windows will include max path. Otherwise, we include path max. I think this is okay. This will be okay. All right, we got our constant. I'm happy. Okay, so let's implement read link. Read link. All right, let's just write it, right? I started with path plus POSIX. Oh, it's already open somewhere over here. Okay. Let's uncomment these lines. Okay, so our goal is, given the current path, read its content as if it's a symbolic link, and we'll resolve the path. What happens if, let's compare, I don't know. I don't want to look at geeks for geeks. Just give me the Python documentation. Thank you very much. Read link. Return a string representing the path to which the symbolic link points. The result might be either an absolute or a relative name. If it is relative, it may be converted to absolute name with join. If it is string object, blah, 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 blah. When trying to resolve a path that may contain a user real path, okay? It doesn't say anything about what happens if the link, if the file, the path isn't a symlink, right? It doesn't say anything about that. So let's just experiment with it. I run Python here, import OS, and then os.readLink package.swift invalid argument. Invalid argument. Is it because it's not a symlink? That'll be interesting. Let's make a symlink here. Guess a.swift to be package.swift. Okay, and if we do this, we'll see package a.swift points to package.swift. And then let's read a.swift. Okay. So it throws an error if it's not a symlink. Okay. So we probably should do the same. All right. And assume, just call read link should do the similar thing. So we read link is right here. It takes the buffer, it takes the string path, and then it takes okay. All right. So I guess I'll do like a try path, and then path will take C string, and C string will take a contiguous array of POSIX encoding unit, and we'll call the initializer with this guy. Whoops, I need to tap that one more time. Here we go. Save some typing, So the capacity we're dealing with is our constants dot max path length. And then for the next part, we can use a trailing closure, which gives us a buffer and a count. Okay, this is pretty long, but no big deal. Need to do this. Okay. Okay. So we need to add an argument saying, wait, really? No terminated string. No terminated. Was it string? Null terminated storage. And it's not on the path. It's here. Okay. Good. And then dude, these things are pretty long, dude. Okay, let's start this on a new line. How about that? Okay. All right, so here we are. We got our buffer. We got our length. And that's all the information we need to do read link, right? We have our, we need to open ourselves up. So there's a thing called binary string. We gonna see this. That gives us the pointer. And then we can pass this pointer. Read link. Yeah. Read link buffer dot pointee. Oh no, base address. and the length of the buffer, which is this guy. On Linux this is so expensive, dude. Okay, so this gives us what? Read link. And read link is a size, as usual, as is typical. Okay, so we take the size, convert it to an integer, and then we can call that our length. Okay, that length equals this. This technically we need to plus 1 here. Now we have the length of the result. We can assign it to the array count. So this will be length plus 1 because we need to put in our storage here. The last character is guaranteed to be 0. Yeah, okay. And then we need to return something here. Binary string. We don't need to return anything. Oh, we need to try. Okay. That's funky. Which Swift version am I using? Interesting. Okay. POSIX plus path. Path plus POSIX. All right. So I think that did create a path, didn't it? Didn't it? Feel like it did. See, the dilemma here is like to test this, I need to write make symlink first. And then to test make symlink, I need this, right? So they're mutually, like, it's a mutual circular dependency as far as testing goes. But I believe that did build something. So why don't we use our iOS example again to do some extra. So the command line argument in ls here will take this guy and kind of just do path, convert it to path, and then do read symlink. Read symlink. Yeah, no, I didn't do error handling neither, so that's something to do, but just test out the basics, you know? And then we'll let the rest of the logic run as normal, as usual. Actually, I have a better idea. Nah, it's fine. Swift run ls a.swift, because we have this a.swift in here. It did give us this, and then it threw in an error. I have no idea whether the error is from ls or not. So let's comment out the rest of the code. Run this again. And this time we didn't get an error. Exit code is 0. Perfect. So we kind of know this works. Nice. So let's move on to Windows then. Again, it's always a little bit more complex than you think. Make code gen. So a little bit more complex than you anticipate. For example, this time we figure out the constants, right? While I'm here, let's try to build this thing in Docker. Oh, I'm so glad I did. Also, pass plus POSIX. Yeah, so this base address is explicitly unwrapped on POSIX. Okay. I'm just going to unwrap here. And I forgot to handle error. So under what circumstance will we throw? Let's read. If it's a -1, then we'll throw. Okay. So if length is -1, throw system error with the code. Error no. And the indentation is funky here. Okay, so now we're throwing the error. I feel much better. So if test Docker. Oh, make test Docker. Okay, things looks normal. Actually, I probably want these to be internal. And then we go to sources, just add them all, right? And then we can claim implement read symlink for POSIX. Okay. Let's check our previous work. Is this it? Did I blow up by that much? Yeah, it passed. We need to squash and merge. We need to close this issue. And we need to move that card. Okay, that card moved itself. Okay, good. I guess let's go to Windows. let's go. Turn over. Read symlink. Okay, like I said, I did some prototyping on Windows as research. So let's just look at that, not this, right? So apparently this is what you do. You call this function get final path name by handle W, and you're done. Of course, you need to get your handle first, so you get your handle. Yep, and you're done, truly. Okay. I'm gonna put this over at the left as a reference. And then over here, we're gonna open paths plus Windows. And we'll just start writing, right? Public function read symlink, right? It throws, it returns error, sorry, path. Wait, what if we read something that's not a symlink? Let's see. So Swift run package. Does this error? Give me an error. Wait, that's not the error I expected. Oh, it is. It is some error. Okay. Let's look at what POSIX error code 22 is. Is invalid argument. Okay, that's the same one I think Python throws. So that's really good. Okay. Yeah, so again, our goal is to create a path, right? I'm gonna open up path plus POSIX. Just look at the shape, because I think it will be very similar, because we start off by calling a path initializer, right? And then in here, inside of here, we need to make a C string, right? And inside of here, we give it the infamous null terminated, what do they call it? Storage, which is a contiguous array of type Windows encoding unit. And that opens up its own initializer, starting with the unsafe initialize capacity being constants dot max path length. Yeah, so far is identical to the Unix implementation. Then we get our buffer, we get our count variable that we need to set. Okay, and then we start copying code from ourselves on the left of the screen. I'm sorry, I think you guys can see it. I'm so sorry. Okay, here we go. Yeah, so just narrated myself typing out this part, okay? In case you're wondering what you missed. Okay. So we have a binary string from the self path. What we need to do is binary string.c, right? This will give us a block that has a C string in it. Also, I think this block should rethrow. I need to check. But yeah, so inside with having the C string, we can take this block of code and create a handle. Okay. We take the handle and we close the handle. Close handle. Oops. Oh, the indentation is not really pleasant. And if I think there's a lot of code here that's repetitive, really. Okay, so we have the handle now. Then we can start. I guess we already started some of these. So we can do this, right? We already are inside of this storage block. Yeah, right after here. Let's see if we can get this right. Okay. So we take our handle, we give the function, the Windows function, our base address. Yeah, this should be this +1. I'll do the same here. Pass this. Everything else should be okay. Now we've set our everything else. I think this is it. Script, I guess, make, build. Hey, everything built. Now I'll do the same thing with the LS example, I guess. What did I do here? We will make a path out of command line. Right, make this, and then we call read link. Not read link, read symlink. Read symlink, and then we'll print the result. How about that? Okay, let's build again. And then we can run build windows bin ls a.swift. Yep, a.swift end up being package.swift. What if I run package.swift? Package.swift end up being package.swift itself. So that's a little different in terms of behavior, right? Maybe I can do the same thing on POSIX, but let's check in the changes. Sources, pathos, windows. Yeah, that's good enough. Implement read symlink windows. Nice, my research paid off. Okay, let's switch back to the other computer. And well, you know, we'll make, I don't know. I don't know what to do. Should I make it consistent on both platforms? I think it's okay to make it consistent. Yeah. If I guess metadata try metadata file type is symlink, If not, same link, we just return self. Or rather, I can just guard. Yeah, this way, yeah, it's a little bit more ergonomical. As in, like, if you accidentally use it on a normal file, you can use it essentially fearlessly. Something isn't up. I feel like calling metadata has to be throwing, right? Has to, oh, I see. Now you're gonna complain about not having try. Okay. Oh, it's thinking. The computer is thinking. Ah, it's doing that thing again. Okay. Ever since I installed the torching from trunk, I see that error sporadically. Okay. So we ran with a non-same link, and then we got its own value back. Great. Sources x base. Guess check out tests. Check out examples. Rebase. Oh. Squash, I guess. Fetch origin. Rebase origin. Read same link. Guarantee writable temp directory from the 218. What? Okay. Yeah, 4 commits? No way it's 4 commits. Yeah. 3 commits. Path plus Windows. What is the... Wait, what? I guess I can just ignore all of this now. Ignore this part. Okay. Just for sanity check, Okay, this one adds the constants. This one implements read symlink in POSIX. This one implements read symlink in Windows. Okay, looks good. Let's force push this. I'm trying to decide whether there's something else I want to do today for the stream. Okay, read symlink. So there will be a ticket closed by this, and that would be number 171. Closes 171. This is non-tested, but I'll add tests later. And all three commits I want to keep. I have to manually link the issue because GitHub is full of lies. Yeah, but let's see what else. Is there something else I want to implement for this in this 2-hour plus stream already? I can try to implement a symlink, creating symlink. Let's see how does one do that. Symlink. Create symlink. There we go. Create symlink. You take the target. You take the symlink source and target. And you give it some flags. What are the flags? Symbolic link directory, file. Allow unprivileged create. Specifies to allow creation of symlink when the process is not elevated. Developer must be first enabled on the machine before there will be function. Okay, so probably not this. So I need to know myself whether, we can make this, right? Because this seems pretty simple. Famous last words, but it does seem like a doable thing. Remarks. Symlink can maybe be absolute or relative links. Absolute links are links that specify each portion of the name. Okay. 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 This makes me think maybe one thing we need to do is once we retrieved the yeah, I don't know. I'm not sure. I realized the Windows implementation is slightly strange because it turns a relative path to... Actually, I don't know whether it's strange or not. Get final path name by handle. Retrieves the final path of the specified file. I guess it's fine. I kind of, for some reason... want sorry, I was starting to say like it feels wrong that this link is I don't know. I don't know what how Windows does symlink. Let's switch to Windows, right? So I have a symlink. I have a link file here. Can I open it up? So if I just open it, it will just actually open the target. I don't know. Windows show symlink target. Yeah, I guess this there does show its target, right? So it's a little weird that our API retrieves the absolute path of the target instead of, yeah. So I think in that sense, the symlink implementation is wrong, right? One thing, like I guess invariant I want to maintain is, say I create a symlink in my library, and then I read the symlink from that file. I should get the same value I put back when I put in, right? So Windows read symlink. What is the right way to do it? Read symlinks in Windows. Make link. There's no change how to call make link. Create symlink. There's an API. You need to set allow on privilege create. For their animals contains 3 files: cat, dog, and fish. The make link command is executed to create a symlink called pet. I'm gonna point it to the animal's dog. We draw on because listed, the symlink can be seen in yellow, purple when the content are queried. Okay. Once created, symlink get opened just like any other file. How do I try it? Okay, so this is not super helpful. Symlink. Nah. Read symlink API. Also, this is relatively new, so I need to be, I guess, a little bit of cognizant of that. So I'm pretty sure with this business, my constant for Windows for max length is wrong. So I need to fix that, but I'll do it separately. So you can try open the link, which would return the handle to the target file. Oh, that's how you do it. Oh. So I used the wrong thing. That makes so much sense. Yeah, all I need to do is you call create file, right? Create file W. No. Hold on. This answer is almost tripped me up, almost deceived me. Where was it? Where was the thing? Okay, let's go back to the answer and see what it's really saying. Well, actually, I want to open up the documentation as well. Guess we'll just do create file W. Okay. Okay. LP, the file name device we created. You may use the / or /. No, that's not the thing. I want to look at when you open the file. No, it's in what is this answer saying? The answer is like you can try open the link, which returns the handle to the target file. Yeah. Then try to retrieve the file name from the returned handle. It's per here. Okay. The file name. Get the drives. Well, return a handle. If you need to do this on early release, the following example obtains a file name from handle using a file mapping object. It uses the create file mapping map view of file to create the mapping. That uses mapping file name to test this code. Create a mapping file and pass the resulting handle to get file name from handle. Get file name from handle. So what does this do? Let's try to read it, right? Create a mapping. I don't know what a mapping is. I don't know. Of this, that, copy the drive letter. So this is like an implementation of this. Yeah, maybe I'm... Okay, let's try this. Let's see if we can figure out how Python's doing it. Lib os read link. Okay. Def read link. Pathlib. Okay. Just calls os. Okay. That's very cool, dude. All right. So it's where would it be? Where would it be? Read link. Oh, this looks interesting. Read link deep. nt.py. Modules. POSIX module. Is there something like read link at? Okay. Oh, OS read link definition, implementation. Here we go. So we allocate a buffer. We call read link at for some reason. Okay, here. If defined windows. Here we go. They create a file, right? Create a file with these flags. Handle the error. They call device IO control. Oh, interesting. And then wait, it's not over? Got IO result. And then what is all this? Symbolic link reparse buffer. IO result. What is an IO result? This looks interesting. Okay, so this is the C Python C implementation. Let's try it, right? Python 3 import, I guess, os.readLink. I guess we can call ours readLink and makeLink. Okay, readLink a.swift. Yeah, it actually gives the right value. So it's totally possible, and this is the answer. Device IO control. Reparse point handle. Okay, so you make a handle and you give it to device IO control, and then that'll give you the and then you say get reparse point. Okay, so where is device IO control defined? Device IO control. It's in, what's the header? IO API set. Is this part of the Swift Windows SDK? Because that'll end our story right there if it's not. It is not, right? It is not. Oh my. So I can't do it. I don't have device IO control. Well, let's find out empirically. Yeah, if we don't have it, then that's the end of the stream. I need to think about what to do next. Okay, just gonna, I guess, import when SDK. Actually, probably better to do it in here, right? Windows. Okay, so return this, print device IO control.self, and then let's meet our doom, the build failure. Oh, build did not fail. Interesting. So we do have device IO control. So should I do this? What's my branch name? It's like read symlink, right? Read symlink. Cool. Okay, so we just delete everything here, everything we have here, and start over. It's a little sad, but it's okay. Okay. So the first thing we need to do is make a handle that goes create file w. And then guess binary try binary string dot c, because we need this c string here, because that's gonna be our first parameter. Say string, and then create file has been in this file for a number of times. Okay, so we just need to kind of eyeball it there. So there's a 0, there's a 0, there's a nil. And then the next one we want open existing, so it's the same. Then the next one we want file flag open reparse point and backup semantics. Yeah, both. So file flag open reparse point, or with this one, and then do arrow handling, close the handle, all that good stuff. I really should kind of make my own convenient method to do all this. Okay, and then it was like the IO result is device IO control, taking arguments. We give it the handle. We give it a buffer. Okay, this is where we already create our buffer, right? Or rather, our target buffer. What is IO? What does this thing result? What does this thing return? Let's actually look first. I'm pretty excited that this is possible at all. So, device control. Oh, it just returns things in the out buffer? No, and out buffer. Oh, LP out buffer. So this thing returns like dynamic types or some stuff like that. LP out buffer. A pointer to the output buffer that's retrieved the data. The format depends on the input of the thing. Okay. This control code for this identifies the data. For a list of control codes, see remarks. Okay. Control codes in remarks. To retrieve a handle of the device, you must create a format. Okay. Device IO controls handles a specific device. Open A, query file A. Okay. You specify. Oh, list of control codes. Oh my god, there's so many. Okay, so the one we're interested in is get reparse point, which I assume is this one? No. Okay, search. Okay, it's unclear to me what gets returned from that. We can infer that from, I don't know, target buffer. Reparse data buffer, is that a thing? Reparse data buffer. Oh. What is the data structure though? Okay. Let's see how this is defined. Define this. Whoa, what? Why is this defined? The following structure is copied from this. including this isn't present in Windows SDK. Huh. Does this link still work? Oh, it does. Okay, so this is the data structure. Okay. All right, so we need to make one of these and give it. Okay. Reparse data buffer. Okay. Can we call size of in Swift? Import Darwin. Okay, and then time spec. How about that? Can we do size of? No, but I can do mirror reflecting time spec dot stride or something, right? No, not mirror, maybe. What is it? Size of being Swift. Someone has to have memory layout. Memory layout of time spec dot size or stride even is 16 size. Okay, so that's what I need to use. Okay. So next thing is reparse data buffer, right? Var buffer equals reparse data buffer. Feel like some exciting casting action is coming up soon. Okay, this is just creating the buffer, so we can just chill here. And then we call device IO control. We have the handle. Okay. We have fsctl. Oh, sorry. You guys are not seeing what I'm typing. fsctl get reparse point. Then we have a couple of zeros. And then we have the buffer. And we have the size of the buffer. So memory layout buffer dot, sorry, it should be this thing. Dot stride, I think. Probably need to convert it into a D word because that's what's popping on Windows. And then we get the size. Or the size D word 0. Okay. And then another 0 towards the end. I feel like some of those zeros are probably pointers, but okay. So I guess I'll just fatal error. And we'll see how we're faring in terms of compiling. Build script build. Okay. Oh no, reparse data buffer doesn't exist. And device IO control. Oh, dive IO control. Okay. Device IO control. Okay, reparse data buffer doesn't exist. That's troublesome. Parse data buffer. Oh, it's part of this thing. That's probably why. That's probably why they included it. That's probably why they included it in Python's source code. Okay, this is getting interesting now. I have no idea what's the best way to approach this. I can definitely include this data structure. I can definitely include this data structure as part of the code, part of the library. Yeah, but I think for now I'm gonna turn off the stream because like we're approaching 3 hours and it's kind of late for me now. I'll keep working on this though. So I guess this is where I say thank you very much for watching, and yeah, it's been pretty fun. I'll see you in the next stream.